Hello friends, once again welcome you to my channel. So we were discussing basic operational concept in our computer organization architecture course. We have seen the basic theory behind. Now we'll take up on some examples to understand it in a clear manner, right? So see, actually inside your CPU, these registers are there, right? And this control unit and ALU is there. In this diagram, just we have mentioned the components, but we have not shown here the connectivity between them. They are also connected. Then only PC content can go to MAR. IR data will be connected to your decoder. Decoders is connected to your control unit. Then control unit is connected to ALU to perform a particular operation. Control unit is connected to memory. That is shown, right? So actually these components are connected, but as of now we have not shown you that connectivity. Only upper level connectivity between two external components is only shown, that is memory and your processor, right? So we'll take up one example. Say this one, add r1 comma r2. This instruction we want to execute. So see, this instruction is performing add operation. Who will do that? ALU will do that. R1 and R2, where are they? They are inside your processor. R1, R2 are there inside the processor. So if they are inside the processor, do I need to go to memory to bring them? No, never. Only I need to go to memory to get my instruction, because instruction is there in memory only. Then from there, I need to get it into your IR. Then only I can execute it. That part is called as what? Instruction fetch. So how to do it? First is, we know instruction will be pointed by your PC. That content will be given to MAR. Already it is clear. So content of PC is given to MAR. I have given you the address. Then I will tell you, please give me from this. That is, generate the read signal. Again, I know I am faster compared to the memory. So I have to wait till when? Till I get the MFC. Memory will give me, yes, memory function is complete. Then I can do the operation whatever is required, right? Then next is, so see, when we are waiting for memory function to complete, during that time we can perform something. We have to see that whether we can do something before my instruction comes from memory. We can do one thing, we can increment PC to point to the next instruction. So PC content will be incremented. The content of PC will be incremented. Who can do the increment? ALU. ALU is now free. Nothing is there to do for ALU. So ALU will increment the content of PC. Right. So whenever we are waiting, that time there is nothing to do. So PC content will be incremented, because what instruction to be brought from memory is already told to MAR. So we are not doing any mistake here. The next one is, my waiting is over. Because see, whenever we are waiting for someone, that time, see, these days what we used to do, we work on our mobile, we'll do something, whatever we can do without the person for whom we are waiting, we can do. So like that, without the instruction, whatever we can do, that we will continue. So what we can do, we can increment our content of PC, because PC content is already given to MAR. MAR is doing its operation, it is trying to get the instruction from memory, right? So once I get MFC, what does it mean? Data is there on the data bus. That means it is there in MDR. So whatever has come into MDR will go to what? IR, because it was an instruction. So basically what I have got till now, the binary combination representing this instruction, maybe some 1010 form is there, that is there in right now IR. So this part is done. This is instruction fetch. After that, what I will do? Decoding. After doing decoding, I'll come to know that we need to perform add, and our operands are there in the registers, right? So to get the operands, do we need to go to memory? No. Why? Because R1, R2 are general purpose registers. They are part of our processor. So decode the instruction. Now I know what I need to do, and I need not have to go to memory. What I have to do? I need to add the contents of R1 and R2. Who will do that? ALU will do that. So next part is execute the instruction. So to execute the instruction, who will do that? ALU will perform the operation. What operation? Addition operation. What? Where are the inputs? R1 and R2. So they will be given to ALU. ALU will perform the operation and result will be stored in R2. So see here again how to go to R1, how the result is sent to R2, that part we are not discussing. If at all we need to bring from memory or we need to send to memory, that time we'll be telling the steps. And these are internally being transferred, so we are not discussing it here, right? So here we have seen one simplest instruction, how it is being executed. And these steps comprises my basic operational concept. Instead of writing it in paragraph style, if we write this step wise, it is easier to understand, right? Hope you have understood this one. Now I'll go to the next instruction. Another kind of instruction. This add a comma R1. Here, what I am doing? Here also I am performing add. Where are my operands? One is in memory, whose address is represented by symbolic name A. And another content is in register R1. Then what I am doing? I am storing the result where? In R1. So this I have to do, right? So what I have to do, is that clear? Content of memory location A will be added with register R1 and result will be stored in R1. So this part is clear. Now see how to do it. Who will be pointing to the instruction? PC. So it will be given to MAR. Already it is clear in our last example. Two examples we have seen. Na? Then generate the read signal. Then wait for MFC. And during that time, you can increment the content of PC. That part is not written here because it is along with waiting, we are performing this. And then the data in MDR will come, that will be sent to IR. Done. Then decoding will take place. After decoding, we'll come to know that we need to perform a memory operation to execute our instruction. Yes or no? So we need to perform one memory operation. What operation? Read operation. Because we need to get the data whose address is A from memory. We need to get the data from memory whose address is represented by the symbolic name A. Understand? So we'll do that. So where I need to give the address to get the data from A? Into MAR. And where from I'll get A? From somewhere in the IR. Because instruction is there in IR. In IR it is add is there, A is there, R1 is there in some binary form, right? So what we'll do? Fetch the operand stored at memory location A. So to do that, I have to follow three steps. Give the address, give the signal read, wait for it, data will come into MDR. So we'll do that. See, first is address I need to give to MAR. Where from I'll get the address? From some part of your IR. So instruction register, one part is representing opcode, one part is representing address of your operand. So that part we will load into MAR, right? Then generate the read signal, right? We'll generate the read signal. Then wait for MFC. Please understand here we should not write A. Why? Because here I can see that this instruction I am going to execute. But actually it is stored in memory. It is brought into the processor. In some part of it, the address is there. That is not known to me. Here this instruction is written and we are trying to understand what will happen while executing this. Because of that we know this A. But otherwise the instruction has come from memory. It is there in IR. So we don't know address. It is in some part of IR. So that I have loaded into MAR. Then read signal, then wait. After your waiting is over, where data will come? Yes, it will come into MDR. From MDR, where you need to redirect it? Where? It should be redirected to your ALU, not IR. Please understand, not IR. Why? Because you have not brought one instruction. What you have brought? One operand. Operand will not be sent to your IR. That you need to understand. ठीक है. So MDR content will be given to the input of ALU. Why it is so? Because I am going to perform a ALU operation. Okay. Then see, is it over? No. Till now we have not performed the operation. Till now we have got our operand from memory, and another operand is there in the processor only. So no need to go to memory for that. So now next execute the instruction. So what ALU will do? It will perform the addition on the contents of memory location A that we have brought in my previous step and the content of R1, and the result will be stored in R1. So this much is there as part of execution of this instruction. Hope this one is clear. Then next we'll see quickly one more example. Okay, before doing that, one more thing is there, that when we have executed this instruction, how many times we have referred to the memory. And please understand what is the meaning of memory referred is that once you give some address into MAR and then till the data comes in MDR, this whole sequence is called as one memory reference, right? One address, new address is given till the data comes in MDR. This whole sequence is called as a memory reference. Or after giving one address till one data is written into memory, that is also memory reference, right? So please understand, whenever you have given one address into MAR, that means one memory cycle has started, and one memory cycle means one memory reference. Understand now? So while executing this instruction, how many times we have referred to memory? One is without thinking anything, at least one so you know, that is for getting the instruction. And second one is to get the operand from memory location A. And then do you require any more? No, because result is stored in R1. Where is R1? Inside the processor. So no need to go to memory. So as a whole, this instruction will take two memory references. Hope it is clear. The next one is, so see, this one is clear, to fetch the instruction and to fetch the operand from memory location A, right? Thank you. Again, we'll discuss in my next video also, I'll discuss two more examples on this basic operational concept. Till then, thank you. And if you are liking my these lectures and you are getting computer architecture from this lecture, then please do subscribe my channel and like my channel. Thank you.